Good evening, good morning, and good afternoon, depending on the time you are viewing this video. You're welcome to LFX tutorial. In today's video, we are going to talk about some videos which you have already requested. Most of you have requested both in our WhatsApp group, in our YouTube comment sections, and also our Facebook page. So please, if you are not in our WhatsApp group, better do well to join. We're going to drop the WhatsApp link in the description. In today's video, we are going to talk about stoichiometry. It's a question Jamb cannot do without, and it's a question that if it's not asked in Jamb, it's not going to. It seems as if stoichiometry question is not complete. So if I were you, I will settle down, keep quiet, and listen. As in, just put your mind at rest, because in LFS we are going to break this particular problems down into pieces. So what you are going to do is, for you to now learn this particular stoichiometry, we are going to divide this stoichiometry video into some parts. So in this particular part, we are going to talk about the general stoichiometry, how to solve stoichiometry, how to approach stoichiometry. They will now have to now do. Now, in this particular stoichiometry is basically divided into two. We have the one we call the ideal stoichiometry, and we have the one we also talk about limiting reactants. So we are going to talk about those ones. We'll talk about the difference between those ones. We'll divide this thing into two, and after everything we'll start solving questions based on those ones we divided. So let's now go. So we have this one, ideal stoichiometry. Then we'll have limiting. Let me just use LR here. So in under ideal stoichiometry, we have something we call mole to mole. Then we have something we call mole to mass. Then we have something we call mass to mole. Then we have mass to mass. We have mole to volume. We have volume. We have volume to mass. We also have other ones like mass to volume. So we have different reasons. So these are the lessons we are going to. Before we start talking about mole to mole stoichiometry, which is the first thing we are going to do, first of all, I want to give you an overview of all those things, whether you have an ideal or limiting reactants. How will you do it? Now, the overview is going to be like this. We have something. The first thing, if you look at this particular thing, what they concentrate is something we call mole. So this is mole here. This is mole. Then, if we talk about 1 mole of a substance, a mole of a substance is the same as the mass of that particular substance. For example, let's use for example, we have this is hydrogen now. If we talk about the 1 mole of this hydrogen, it's going to equal to what? What is the mass number of hydrogen? What is the atomic mass number of hydrogen? Is what? Is 1. So 1 mole of this hydrogen is equal to what? 1 gram of this hydrogen. 1 mole of it is equal to what? 1 gram of this hydrogen. That's what it is. So this 1 mole is what? Is equal to 1 mole of a substance is equal to what? Mass in gram of that particular substance. Mass in gram of the substance. Now, another thing you have to note is that 1 mole of a substance is the same as 1 mole of this substance is the same as the number of a particle inside this particular distance. Yeah, the Avogadro's number. We have, let me just say AN, which is Avogadro's number. And the Avogadro's number is what? 6.023 times 10 to the power 23. Then, particles now. 1 mole of a hydrogen is the same as what? We contain 6.023 times 10 to the power 23. You see it now. We have 1 mole is equal to the mass of this. We still have 1 mole is equal to Avogadro's number. Then 1 mole of this particular substance is equal to the what? To the volume at STP of this particular substance, which is what? 22.4 dm cube. 22.4 what dmq, and it's also equal to the what, the room temperature of this particular substance, which is 27.4, something like that. So have it in mind, the 1 mole of this substance is equal to this, and the same 1 mole of this substance is also equal to the what, the number of charge of this particular substance, which is what, 96,500. So now you see all these things I've showed you now. These basics I've showed you now. Let's now use this thing for example. If you have 1 mole of a hydrogen which is equal to 1 gram, and 1 mole of this hydrogen which is equal to 6.023 times 10 to the power 23, and we still have this 1 mole of this thing that will carry the charge of what, 96,500 coulomb. If I now ask you now, 1 gram of hydrogen will carry how many particles? What does it mean? 1 gram of hydrogen will carry what? 6.023 times 10 to the power what? 23. So it will equal 6.023 times 10 to the power what? 23. 1 gram of hydrogen will also carry the charge of what? 96,500 what? Coulomb. Have you seen how all these things are interconnected? So 1 mole or 1 gram of hydrogen will contain, it will be at STP will have a volume of what? 22.4 dm what? Cube. Have you seen how all these things are connected? Now let's now go back to our stoichiometry. What brought us to this? Now if we now talk about stoichiometry, now stoch, which means calculation, and metry, which means what? Elements. Now if we want to talk about this, we have to mole now. What does it mean? You have to have in mind that what you want to calculate is two species of a substance. If they give you a question and now say you should calculate for a particular substance, they will specifically give you what you are calculating for. For example, now I may just give you, they will just say is you find how many moles. I've listened to them. They just say how many moles are there or are produced when something moles of this. Have you seen now? They said when something moles of this. What are they asking you? Mole to mole. Mole to mole. How many moles of a substance are produced when some certain moles? Which type of stoichiometry is that? Mole to what? Mole. So then I ask you now, how many moles of substance are produced when mass of this particular substance reacts or something is used? That means mole to what? Mass. So I know you can guess this last one. How many mass of substance will produce when mole of this certain mole of a substance is used? Is reacted? Have you seen this word? Mass to mole. This is how it is going to be happening. So for this particular one, this is the easiest one, which requires one formula. As in one, this thing, we have this one, which is what? 2. We have this one, which is 3. Then I'm going to give you the general this thing of solving this, approaching this. First thing to do when you have stoichiometry, first thing to do is for you to write chemical reaction. Write the chemical reaction of that particular thing. Write the chemical reaction. So write the chemical reaction or chemical equations of the reaction. Chemical equations of the what? Reaction. That's the first thing to do. Now, second thing to do is for you to balance that particular chemical reaction. One thing about it is writing. The second thing is also to what? To balance. For you to do what? Balance it. So the third thing to do is for you to do what? Identify the species of what they told you to do. If it is mole to mole, identify it. If it's mole to mass, identify it. If it's mass to mole, identify it. That is the third thing to do. Remember, the third one is for you to identify the species. Then the fourth thing to do is for you now to do what? To convert. If it's not mole to mole, if they give you mass to mole, as a mass to mole, and it was a mole, convert. That is what you are going to do. So we are going to be looking at one question briefly. Our first question, you see that how many moles of what? Calcium oxide is produced when 2.5 moles of calcium carbonates decompose under what? Heating. So what is our question now? Moles of this. and moles of this. Did you see it now? Moles of this and moles of this. This is what? Mole to mole what? Stochiometry. Once you see this in Jamb, start laughing because we only have what? One formula. So what are we going to do? First thing I told you to do is for you to write your chemical equation. So our chemical equation here is decompose. Once you hear decompose, that means this is a what? A decomposition reaction. So in this decomposition reaction, first thing to do is for you to write your compounds. So now this is a decomposition reaction. So once you decompose, we are going to form something like this, and we now have oxygen gas. This is what we form from this particular reaction. First of all, I said first thing is for you to write the chemical equation. The second thing is for you to balance it. So let's balance this. How many calcium can you find here? Is 1. How many calcium can you find here? Is 1. So how many carbon can you find here? Sorry, we're supposed to have CO2 here. So we're supposed to have CO2. So how many carbon do we have here? 1. How many carbon do we have here? Just 1. How many oxygen do we have here? We have 3. We'll have 3 here. We have 1 oxygen here. We have 2 oxygen here, making it what? 3. Now, if we want to now write this thing of the ratio of the reactions is 1. This is what? 1. This is 1 mole. This is what? 1 mole. This is what? 1 mole. Now, the question is going to be how many moles of what? Calcium oxide is produced. So first of all, second thing is for us to identify the species that they ask us. Remember that the species are asking is just 2 species. That's what you're going to explain. There are some questions, you see something like 3 species reacting. What you're going to do is for you to identify the one they are giving values for. Do you understand now? They may even tell you that if it is one that has to do with something like direct reaction, they will tell you that this one reacts with this. But they will tell you the one they want you to use, you are going to do what? You are going to, they're going to give you the values of that one you are going to do what? Use. So now listen to this one. This one they just gave us 2 values. Now listen to this one now. We have 1 reacting, we have 1 reacting, we have 1 reacting. So now for the question now, they gave us 2.5 moles of this. Moles of this. Look at the 2 that is reacting. They are going to identify here. Before it was 1 and 1. Now we now have what? X here. Do you understand now? We have X here. So the thing we are going to do now is that if we have 2.5 moles of calcium carbonate, how many moles of what? Calcium oxide is going to react? So first thing we are going to do is that when 1 mole, so now we now have when to 1 mole, so for us to solve, 1 mole will react with what? We produce 1 mole of calcium carbonate, we produce COCO3. We decompose to form calcium oxide. Then 1 mole of calcium oxide. Then if 2.5 moles of calcium carbonate decompose, what are we going to form? X. So without even solving this particular question, you saw that 1 mole will produce this. What will 2.5 mole produce? Virtually we are going to do what? We cross multiply. If we cross multiply it, 1 times X will give us X. 2.5 times 1 will give us what? 2.5 moles. So the answer is for 2.5 moles. So what will happen is that 2.5 moles of calcium oxide will be what? Produced. Even though this question seems is very easy, but the only thing why I use this question is for you to know the steps. So we are going to do something, a small harder question, which we are going to do see on mole to mole. We are going to do 2 examples on mole to mole. Then we'll now move to mole to mass and what? Mass to mole. So just make sure you see. If you're liking this video, make sure you give us thumbs up because it's not easy. The number 2 question will say, given 2 moles of, you can see that this one will be a little bit hard more than the other one. We're doing it step by step. So you learn the basics from the other ones, then this one will now give you about. So we now have, given 3 moles of nitrogen gas, how many moles of ammonia will be produced. First thing we know is that first thing we should write our what? Our chemical equation. That is our first thing we are going to do. So have N nitrogen gas. So they say we produce. That means this particular one is going to be on the product side. What will react with nitrogen gas to give us this? We have our what? Our hydrogen gas. So when our hydrogen gas reacts, it's going to give us what? Ammonia. Remember, this is ammonia. Now, I said the first step is for you to write the chemical equation. Second step for you to balance it. Let's balance this. How many nitrogen gas we have? We have 2 here. We have what? 1 here. So what are we going to do? So we have to balance here to be 1. So once we balance here, we now have our nitrogen is balanced. Nitrogen is balanced. How many hydrogen do you have here? You have 2 here. How many hydrogen do you have here? 2 times 3 is going to be what? 6 hydrogen. So how many can we put here? It is going to be what? 3. Now, this chemical equation is familiar. Which chemical equation is this? This is Haber process in production of what? Ammonia. Under a catalyst of what? Phenane solution. If you can remember, if you read your nitrogen distillate level. So let's move on. About that. The third one is for you to identify the species reacting. What are the species reacting? 3 moles of this. 3 with the species they're asking is this and what? And this. This is the species they're asking you. First of all, let's check the ratio of what is reacting. 1:3 ratio what? 2. That's what is reacting here. 1:3 ratio what? 2. That's what is reacting. This is 1 mole of this, we produce this. Now, if you are given 3 moles of what? Of a nitrogen gas, how many would you now produce? Now let's now move. Our solution will now be, since 1 mole of nitrogen gas produces 2 moles of NH3. Since 1 mole of this will produce what? 2 moles of this. How many moles, as in when you are given 3 moles, how many of this thing will you now produce? You now put 3 moles of nitrogen gas will produce what? S moles of NH3. First thing to know is that this is just like a basic stuff. You have 2 Maggi, you are able to use to cook 4 cups of rice. When you now have 6 cups of rice, how many Maggi can you use and cook it? Don't worry, I like food. So let's go back. So now we have 3 moles of this. Let's cross multiply. We'll cross multiply. We'll cross multiply. So we have 1 times S will give us what? S. 3 times 2 will give us what? 6. So what is going to be? That means 6 moles of NH3 will be produced. I know you are enjoying the video, so let me give you one you are going to do. So if you do that one, so we are going to start our next video on stoichiometry, the part 2. Before we will close the video, I'm going to give you the number 3. You are going to solve it and draw the question in the comment section. So make sure you watch our mass to move. In that particular video, we are going to cover mass to move. I don't want this video to be longer. Mass to move, we cover mass to mass, we cover mass to volume, volume to mass, all those etc. So we are going to take number 3 questions now. We are going to solve it in the comments description. That will show you in the screen will be a question you have to solve. If you solve it, just drop it in the comment section. If you enjoyed our video, please make sure you give us thumbs up, drop a comment there that you like our video, show appreciation, share this video with your friends that are preparing for Jamb so that they will also see this good stuff. Now, if you haven't subscribed, please do where to do that. That's any motivation we get for producing all this video.